Theory of plate tectonics. So, the evidence of seafloor spreading suggests that continental and oceanic crust move as enormous slabs. Tectonic plates are huge pieces of crust and rigid upper mantle that fit together at their edges to cover Earth's surface, and there are 8 major plates and several smaller plates. Now, this movement is very slow. It's only a few centimeters per year at it's about the same rate that your fingernails grow. So these move very slowly. So these are large plates of crust and upper mantle. And again, there are 8 major plates and several smaller plates. So plate tectonics is the theory that describes how tectonic plates move. They move in different directions and interact with their boundaries. So wherever their edges touch, so you have one plate here, that would be your boundary. Each type of boundary has certain features and processes. And there are 3 types of plate boundaries. We're going to talk about all of these individually here in a second, but in general, you have divergent, which is a boundary where the plates are moving away from each other. So you have one plate moving this way and one plate moving this way. You have convergent, where plates move toward each other, so they are colliding basically. And then transform boundaries, where plates slide past each other. So you have one maybe sliding south and one sliding north. Okay. Now we're going to talk about all of these individually. So just to get an idea of where some of these plates are and some of these different boundaries, you have, say, the African plate, and you kind of see the outline of Africa on the African plate here. It does include part of the Atlantic Ocean. You have the South American plate here. We have the North American plate here. And again, you kind of see the outline of the countries on the plates, but the oceans are also on these plates as well. You got Eurasia, which is basically all of Europe and Asia. The Antarctic plate, so Antarctica is basically on its own plate, etc. So, divergent boundaries. So divergent boundaries are regions where 2 tectonic plates are moving apart. Most of these are found on the seafloor and rift valleys, but some occur on land. Now, this is the place where seafloor spreading begins. We talked about the mid-ocean ridges. Well, this is basically where the mid-ocean ridges are, is at these divergent boundaries. Now, magma rising up through the rift's faults forms a mid-ocean ridge and also forms new oceanic crust. And this results in high heat flow, volcanism, and earthquakes in those areas. Now, that's if it's on the ocean floor. Now, if it occurs on land, we have a rift valley, which is a long, narrow depression that occurs when continental crust begins to separate. So if you have continental crust separating, you end up with a rift valley. So you basically end up with this area where you've got these slopes on both sides, and you have this big, wide valley in the middle. That is occurring on the east coast of Africa right now, like over near Madagascar and the Indian Ocean. So convergent boundaries. So at convergent boundaries, 2 tectonic plates are moving toward each other, so they are colliding. Okay. Subduction is a process when a denser plate descends below a less dense plate when 2 plates collide. So convergent boundaries, a lot of times you will have subduction. So you have one plate, you have another plate that collides, it's denser, and it will actually sink below the less dense plate. Now, there are 3 types of convergent boundaries classified by the 2 types of crust involved. So you have the 2 main types of crust. You have oceanic crust, which is mostly basalt, which is high in iron and magnesium, which makes it dense. So oceanic crust is very dense. That's kind of what this is here. So you have these rocks that are high in iron and magnesium. Then you have continental crust, which is composed mostly of feldspar and quartz, which we said are silicates. So these silicate minerals are less dense than the basalt rock. Okay, we actually call this granitic rock, like granite, which is basically what this is. So the first type of convergent boundary we're going to talk about is oceanic-oceanic. So this occurs when you have two oceanic plates collide. So you have two plates that are fairly dense, both made of basalt, and they collide. Now, one plate is subducted under the other plate, creating an ocean trench. The subducted plate carries water with it, which lowers the melting point. So if you have water mixed in with the rock and sediment and stuff, it's going to lower the melting point. Magma rises to the surface and forms an arc of volcanic islands. So you get this volcanic island arc here. Okay. These islands run parallel to the trench. So if the trench is here, the islands are going to run parallel to that. The Mariana Trench and the Mariana Islands is one example of an ocean trench and island arc. And again, these are two plates of basalt. The one plate is a little more dense than the other, and it will be subducted, where it starts to melt. And as it melts, this magma rises up to the surface, creates these volcanic islands. Now, we have oceanic-continental. So if we have an oceanic plate collide with a continental plate, we have this oceanic-continental convergent boundary. Now, the oceanic plate is denser, so it is subducted under the continental plate. There's not really a question about which plate's going to be subducted here. So your oceanic crust on this side is going to be subducted underneath the continental crust over here. Okay, and as it's subducted, you're going to have the same sort of thing. You're going to have the plate start to melt. You're going to have magma rise up, and you're going to end up with this volcanic mountain range right on the edge of the continent. Okay, so this also produces an ocean trench. So there is another ocean trench produced here because you have the subduction zone. But instead of producing an arc of volcanic islands, oceanic-continental convergence creates volcanoes on the edge of the continent. So you have the Andes Mountains as an example. The Andes Mountains are on the west coast of South America. This creates a mountain range with many volcanoes in it. And finally, we have continental-continental. So this occurs when you have two continental plates collide. So this occurs long after an oceanic plate is converged with a continental plate. Remember, though, you do have your oceanic plate. Your continental plate is going to have a bit of oceanic crust on it, along with your continental crust here. Okay, so this will be your continental crust. This will be your oceanic crust. So eventually, the ancient oceanic crust gets subducted to the point that the two continents end up colliding. So the continents are usually attached again to oceanic plates. After the oceanic crust is subducted, the attached continent moves toward the subduction zone. So these basically keep coming together. Neither continent is subducted. So if you have two pieces of continental crust come together, they are too thick. They are both relatively less dense than the material that's underneath them, so they're not going to be subducted. Instead, what they're going to do is crumple, fold, and uplift to create mountain ranges. So the edges of these continents basically will be lifted up to form mountains. Sort of like the Himalayan mountains are one example of this. And again, this is granitic type rock, so you have granite.